Hi, everybody. Happy Friday half day. For today's lesson, we are continuing to look at solving one-step inequalities. Yesterday, if you recall, we looked at one-step inequalities with addition and subtraction. You had something that probably would have looked like this, roughly, to solve it. Okay, just as a quick reminder, to solve it, we solve it just like an equation. We would subtract 2 from both sides, and we would get x is greater than 8. Okay, very, very similar to solving equations, just instead of an equal sign, we have an inequality sign. Well, today we're going to continue that conversation, but we're going to add a little bit to it. Today we're going to focus on how do you solve inequalities that have multiplication and division in it. So it's actually a little tricky today. It's probably the hardest part of solving inequalities is with multiplication and division. It's a little bit different than equations. So just as a little preview, okay, if I had something that looks like negative 5x is greater than 10, right? If we would go about solving this normally, we would divide by negative 5 on both sides. And we would get x is greater than negative 2. Well, surprisingly enough, that is wrong. It is not x is greater than negative 2. And you're probably wondering where the mistake was in there, because it's a little weird. You would have never seen it before. So we're going to investigate this. We're going to find out why that is wrong and how you do get the correct answer. But I just want to do a little preview to show you why it's a little confusing. All right. So the first paper that you're going to need out is this one. Why do we need to flip the inequality sign? Question mark, question mark, question mark. Ooh, weird. All right. So hopefully you have this out by now. Make sure you have a pencil or something to keep notes with. You will be showing this to your substitute to record in the assignment tracker. So use the number line to help you answer the questions in the table below. So how this works, I'll do the first one with you. I'll give you a chance to pause and fill in the rest of them. So the first inequality here is 1 is less than 4. All right. Is that a true or false statement? If true, proceed. Well, 1 is indeed less than 4, so that's true, so we can proceed. Our action then is to add 3 to both sides, right? Come over here, add 3 to one side, add 3 to the other. When you do that, when you complete our action, our new inequality becomes 4 is less than 7. I got that as I did 1 plus 3 is 4. 4 plus 3 is 7. So is our new inequality true or false? Well, 4 is still less than 7, so that is true. I'd like you guys to take a few minutes. I would like you to complete the actions of subtracting 3, multiplying by 2, multiplying by negative 2, dividing by 2, and dividing by negative 2 for these new inequalities. Go ahead and pause the video. Unpause it when you're ready to check your answers. Hopefully you paused it and completed them, because we're going to go over them now. For my action of subtracting 3 from both sides, I get negative 7 is less than 3. That is still a true statement. Nothing changed. For multiply both sides by 2, it becomes negative 2 is less than 10. That is still true. Nothing changed, really. Just the numbers. The inequality is still accurate. For multiply by negative 2, negative 3 became negative 6. Not negative 6, I'm sorry. Negative 3 became positive 6. Whoopsie-doops. Positive 6 is less than negative 6. That is false. 6 is not less than negative 6. So that inequality is no longer true. When we divide by 2, it becomes negative 1 is less than 5. That is true. And for divide by negative 2, that becomes negative 1 is less than negative 4. Yeah. Which that is false. Weird. So out of all of those, we got two false statements. Right? We got this one and this one. So for the first little reflection question down here, which specific actions caused the first inequality to become false? Well, the first one that became false was when we multiplied both sides by -2. Multiplying by +2 stayed true. Multiplying by -2 made it become false. The other one that made it become false was dividing both sides by -2. Dividing by +2 made it stay true, but dividing by -2 made it false. So which specific actions? It would be the multiplying. You should be writing this with me. Multiplying and dividing by negatives. Just as a little heads up, that was not just some random coincidence. Okay, it doesn't have to be that it was 2's there. Okay, any negative that would have happened. Anytime you would have multiplied any negative by any inequality, it would have come out false. So without changing the action, so without changing the multiplying by -2 or dividing by -2, what could be done to make the new inequality true? What could we do to this inequality and this inequality to change it? Give you a second to think about it. If you need to pause the video to think about it, you can. But the answer would be flipping the sign. Right? If I changed this inequality to 6 is greater than -6, right? If I flip the sign, then it becomes true. Same with this one. If I would have flipped that to -1 is greater than -4, now they both work. Ooh, look at that fancy little thing. So without changing the action, what could be done? You can flip the sign. Awesome. And then just summarize what you learned here. Okay, if we put these two things together, I want you to make a general statement here, right? This is very important. This is going to happen every time we have negatives in our inequalities, or at least whenever you're multiplying or dividing by negatives. To summarize, when you multiply or divide by a negative number, you must flip the sign. Have to. If you don't, just like up here, your answer will be false. You must flip the sign. All right, if you need time to copy any more of this down, feel free to pause the video, but I'm going to move on to the next paper. The next paper you should have is this blue solving one-step inequalities. So if you are not ready, pause the video, but if you are, I'm going to continue going over this worksheet now. So just like before, your goal is to isolate the variable. You can solve an inequality just like you would solve an equation. When solving one-step inequalities, think about what's happening to the variable. What is the inverse operation? Once you have solved the inequality, you will also need to graph your solution. One major difference is if you multiply or divide by a negative number, you must flip your inequality symbol. Have to. All right. So looking at the first inequality here, we got 4x is greater than or equal to -20. So if this was just an equal sign, solve it, we would undo 4 times x with division. And this would become x. This would become -5. Now we need to think about what our inequality would be. Did we divide by a negative number? No, we divided by a positive number. Yes, there's a negative number in the answer, but I'm not dividing by a negative. So the sign stays the same. X is greater than or equal to -5. So we have a closed circle at -5, and we shade to the right. Awesome. Number 2, 42 is greater than -14g. Even though g is on the other side, don't let it scare you. We need to divide both sides by -14. 42 divided by -14 is -3. -14g divided by -14 is just g. Notice this time we divided by -14. So we're dividing by a negative, so we must flip the inequality symbol. Instead of greater than, it's going to be a less than. So -3 is less than g. So we have an open circle at -3. And be careful in which direction you shade. The variable doesn't come first. So we're going to shade to the right, right? G has to be larger than -3. Okay. I'd like you guys to pause the video. Go ahead and try 3 and 4. Just remember to undo fractions you multiply. Then come back and check your answers. For number 3, we're going to multiply both sides by 6. That way I'm left with b is greater than 84. Okay, we didn't multiply by a negative, so the sign stays the same. We put an open circle at 84, and we shade to the right. Nice. Number 4, m over -8 is less than or equal to -10. I need to undo the fraction by multiplying by -8. Notice this time I'm multiplying by a negative, so a little scary. We know that when you multiply by a negative, we're going to have to flip the sign. It's going to go the other direction this time. This becomes m has to be greater than or equal to +80. So we put a closed circle at 80, and we shade to the left. All right, gonna flip the paper over. We got 2 word problems to go over quick. All right. Number 5, Lexi made fruit punch for her 4th of July party and split it equally among 50 cups. There was at least 8 fluid ounces of punch in each one. Let X represent how much punch Lexi made, which inequality describes the problem. First thing that's important is that we know we split it equally among 50 friends. Splitting equally means we're going to be dividing by our 50 cups. We're going to be dividing by 50. So that information we know that can either be A or it can be C. Can't be B. We then know that there was at least 8 fluid ounces of punch in each one. The only difference between A and C is the equal to sign. So we know if it has to have at least 8 fluid ounces that it can have 8. So the answer is C. When you solve that, you just multiply both sides by 50, and you get that Lexi made at least 400 fluid ounces. For the sake of time, I'm not going to graph the last one. I'm not going to graph this. We just know that's the answer. Number 6, Valentina is baking jumbo cinnamon rolls for a family breakfast. She uses all of the dough she made to form 12 cinnamon rolls of equal weight. The recipe usually makes 36 ounces of dough, but Valentina made more dough than that so she can have larger cinnamon rolls. Let X represent how many ounces of dough Valentina uses for each cinnamon roll, which inequality describes the problem. Well, I know she has to have more dough than normal, so I know I can eliminate B. And if she has more dough than the 36 ounces, she does not have 36, she has more than that. So the answer would be C, okay, which comes out to 3 ounces. That's all for the lesson. Thanks, guys.